Hey everyone! In this video, I want to show you how to create your own stack using a linked list in C++. So we're going to cover stacks as container adapters. So in short, it simply means that the stack uses an underlying data structure to house and manage the data. We're going to implement our own stack using a linked list in this video. Before we begin, just make sure you understand what a linked list is and how to implement it. If you need a refresher, I have included a couple of video links at the bottom of this video. Stacks are container adapters, which means that they can use different types of underlying data structures to house the data it stores. This underlying data structure can be a linked list, a dynamically sized array, or even a C++ standard library data structure. If you look at the documentation for the C++ standard library stack, you'll notice that it actually allows you to specify the underlying container type. By default, if you skip out on specifying the underlying container, a deck will be used, which is short for a double-ended queue. The stack class simply manipulates the underlying data structure as if it were a stack. It provides an interface from which you can use to manipulate the data structure as a stack. So really, the stack class isn't doing anything. It's merely piggybacking on top of the underlying container it's using. Before we start coding the stack class, let's look at a linked list that's been modified from the previous versions shown in the videos. For starters, all the changes in the screenshot have been highlighted. So I'm looking at a new data member, a list node pointer, which we're going to use to keep track of the last node added to the list. The second change is a method to retrieve this data member, and it's called getListEnd. Two more modifications to the linked list class are in the addItem method, which is pretty much the same, except the only difference is at the end of the member function, where we save the newest node we added to the list into the data member listEnd pointer. In the delete item member function, there's a block of code that I added at the end. Basically, the entire member function for the delete item is exactly the same. At the end, however, what I do is I go over the list until I reach the end node. I then assign it into the private data member listEnd ptr. Now this process is to prevent any errors that could occur if I deleted the last node in the list, which is going to be the case when I'm using the stack class to manipulate this linked list. Implementing the stack class now becomes very simple. So let's look at the declaration for our stack class. Notice that we have a linked list data member, and this is going to take care of all the hard work for us. The constructor is pretty simple, so I'm not going to show it here. All it does is it sets list to null to a new instance. So the push member function, it takes a value to add, and it literally delegates this task to the linked list's addItem method. Pretty simple, right? For the pop member function, which takes off a value from the top of the stack, it simply gets the end value of the list ends node and passes that value to the list delete item member function. Again, it's very simple. the peek function. Now the peek function doesn't take anything off the top of the stack. It merely takes a look at what's at the top. And this is pretty simple. We simply call the getListEnd member function, and then call the getValue member function on the returned pointer to take a look at the end node's value. And remember that the end node's value is the top of the stack. The size member function is even simpler. We simply call the size member function from the linked list class and return it. Now let's test the output. Here in this code I've added 6 numbers, so 25, 33, 100, 1, 3, and 44. I then output all of the numbers by popping them off the stack one at a time. And it does go to show that it works. The last data item I added to the stack is actually the first one I took out. And that's why the stack is also called a last in first out structure. The last item in is the first item you pop off. In closing, you can use many more data structures to implement a stack. The stack adapts the underlying structure to fit its needs. The implementation shown in this video is very bare bones, and you'll notice it's quite inefficient in several areas. I'll leave it to you to improve on it and make it as efficient as possible. When you're using a linked list to implement a stack, here's a tip for making it efficient. Try and eliminate the amount of times you need to traverse the list. And you can see that I did implement one shortcut by actually having a pointer to point to the end of the list. This saved me from having to move over the entire list each time I wanted to peek at the value at the top of the stack. A huge recommendation I would offer you is to read up on the C++ library's documentation for the stack template class. There's a lot of good ideas there, and you could get a lot of information. And again, ideas on how to implement your own stack. And yes, if you're wondering, you can turn the stack class shown in this video into a template class too. So that's it, everyone. I thank you so much for learning and for watching this video. I hope you enjoyed it. If you want to contact me for any tutoring sessions, just go to my new website at concordspark.com. Thanks again.